All right, this is chapter 1, lesson 2, multiply fractions and whole numbers. So we have a commuter train travels back and forth, but does not change the distance traveled, okay? So we have this train that's going back and forth. Now so say it's going from Steelton to York, okay? The train goes from Steelton to York and then back from York to Steelton. Okay, it stays on the same track, doesn't actually deviate from anything, so it doesn't change the time. The distance traveled does not change. Okay. In math, operations that follow the blank blank, in those two blanks you're going to write commutative property. So in mathematics, operations that follow the commutative property can be performed in any order. So like the train, it doesn't matter what order it goes in, it's still traveling the same distance. Okay. So for example, addition and multiplication are what are considered commutative. Okay. So a couple examples. So when I multiply a whole number by a fraction, so I write the whole number as a fraction, multiply the numerator, and multiply the denominators. So, for example, I have 5 times 3/4, so I can rewrite 5 as 5 over 1, and then times 3/4, so I multiply my numerators together. 5 times 3 is 15, 1 times 4 is 4. So I get 15 over 4, which I can change to a mixed number. 4 goes into 15 3 times. I have 3 left over and 4. Either of these answers would be correct unless it specifically asks to leave it in an improper fraction or for you to write it in a mixed number. Okay. I can also multiply a fraction by a whole number. Okay, so again, we're dealing with the commutative property, so it doesn't matter what order I do it in. When multiplying whole numbers and fractions, the order of the factor does not change the product. So 4 times 3/5 is the same thing as 3/5 times 4. This is an example of the commutative property. Okay, so I have a couple more examples here. The first one I have is find 2 and 2/5. So the first method I could use is an area model, which we can see over here. Okay. I shade 2/5 of each of the first two columns. So I have 2 full columns. I've broken each of those columns into 5s because that's my denominator. So I break them into 5s. And then because I have a numerator of 2, I shade 2 in each of the 2 columns. Okay. So then when I combine them into 1, I have 4 of the 5 shaded. So 2 times 2/5 is the same as saying 4/5. Okay. For method 2, I can use the equation. So 2 times 2/5, I can rewrite 2 as 2 over 1. So 2 over 1 times 2/5. I multiply my numerators. 2 times 2 is 4. And 1 times 5 is 5, so I get 4/5. So either of them would work. Okay. Example number 2 is find 1/4 of 5, or times 5. So 1/4 times 5, 1/4. I rewrite 5 as 5 over 1. So I have 1 times 5, which gives me 5, and 4 times 1, which gives me 4. Okay. I can leave it as 5/4, or I can change it to 1 and 1/4. The third example I have find 3/5 times 4. So I'm going to use an area model for this one. So I have 3/5 times 4, so I have 4 columns. They're broken into 5 sections each. I'm going to shade 3/5 of each of those columns. So I shaded 3/5 of each of those columns. So there are 3, 6, 9, 12 that are shaded out of the 5 that are here. So a total of 12/5. So 12 shaded of the 5. Okay. Or I can rewrite that as a mixed number of 2 and 2/5. Okay. So again, method 2, I could use an equation. I have 3/5 times 4, which is the same thing as saying 3/5 times 4 over 1. Okay. Multiply the numerators, 3 times 4, and the denominators, 5 times 1. So I get 12 over 5, or 2 and 2/5. Okay. So either of those methods will work. Completely up to you which one you would like to use. Okay. On page 71, there are a couple of try it problems. I want you to go ahead, pause the video, try them out, and when you're done, we will go over the answers together. All right, now that you've tried out the try it problems on your own, let's go over the answers together. Letter A says 6 times 2/3. Okay, so I'm going to rewrite 6 as a fraction. So I have 6 over 1 times 2/3. I'm going to multiply my numerators together. 6 times 2 is 12. And I'm going to multiply my denominators. 1 times 3 is 3. Okay, so I can leave it as 12/3, or I can simplify. 3 goes into 12 4 times. So I'm just left with 4. Letter B says 9 times 1/3. Okay, so I'm going to rewrite 9 as a fraction, which is 9 over 1 times 1/3. Okay, multiply my numerators. 9 times 1 gives me 9. 1 times 3 gives me 3, which simplifies to just 3, because 3 goes into 9 3 times. Letter C says 4 times 1/8. Okay, I'm going to rewrite 4 as a fraction, so I have 4 over 1 times 1 over 8. 4 times 1 is 4. 1 times 8 is 8. Okay, I can divide both of these by 2. 4 divided by 2 is 2. 8 divided by 2 is 4. I can again divide by 2. So this gives me 2 divided by 2 gives me 1. 4 divided by 2 gives me 2, so I get 1/2. Okay. Letter D says 1/2 times 3. Okay. I'm going to rewrite 3 as a fraction, so I have 1/2 times 3 over 1. Multiply straight across. 1 times 3 is 3. 2 times 1 is 2. So I get 3/2, which I can also write as a mixed number. 2 goes into 3 one time, and I have 1 left over. So 1 and 1/2. Okay. Letter E, 2/5 times 4. So I'm going to rewrite 4 as a fraction. Multiply across. 2 times 4 is 8. 5 times 1 is 5. 5 goes in 8 one time. I have 3 left over, so 1 and 3/5, or 5/8, either is correct. And for letter F, I have 3/4 times 5. So I have 3/4 times 5 over 1. 3 times 5 is 15. 4 times 1 is 4. 4 goes into 15 3 times. Okay. And then I have 3 left over, the denominator of 4. So 15/4 or 3 3/4. And that is the end of lesson 2.